Hello everybody. I am sure that many of you will be knowing what GPS is. But have you ever wondered how GPS works? Or what its history is? Or what so errors occur in its accuracy? Basically, to find your position in GPS, there will be 3 to 4 satellites which will be surrounding you, and the point where all the satellite signals meet is the place where you are present. Sounds simple, right? Coming to the history of navigation, actually in olden days, people faced so many problems of navigating themselves that where am I existing now while traveling? If you take Columbus also, rather than coming to India, he discovered United States by losing his way. The word navigation is a combination of two Latin words, navis which means boat and agere which means guide. Military people also faced a great problem of tracking themselves and enemies while traveling in forests or on hills. This particular difficulty brought out Ivan Alexander, Branford Parkinson, and Roger L. Easton to invent global positioning systems, so-called GPS, to come onto the world. Actually, this project invention came on 1973. In the early days of invention, the technology was just used by the military people, and later on, in 1991, it was also open to civilians, and in 1995, it became fully operational. Today, the word navigation is used in broad sense. Navigation system defined as a system providing useful information or determine the position of a boat or a car or an airplane or even yourself, and GPS is used in automobiles for navigation. Dear friends, let me mention that there are basically three components in GPS. Those are space component, control component and user component. Now let us discuss how these components actually work. Actually, what is happening in this technology? Currently, there are 24 satellites working in GPS. But in case of any technical error in any one of the 24, further satellites will be launched. Dear friends, to find the actual position of yourself where you are traveling, you first have to find the distance between your vehicle and the satellite. To find the distance between your vehicle and the satellite, let us assume that you are moving in a car and a satellite is tracking your GPS. As many of you would be knowing that the formula of distance is the speed multiplied with the time. Here, to find the distance, we need two components. One, the speed of the wave. Second, the time taken by the wave. The speed of the wave is nothing but the speed of the light, that is 30 crore meter per second. If you take this as the wave traveling from the satellite to your car, that means the time taken by the wave is nothing but the time taken by the wave to travel from satellite to your car. That could be 1 second, 2 seconds or 3 seconds or any numerical value. Then the distance is simply the product of the speed of the wave and the time taken by the wave. And now distance is found between yourself and satellite. Then how to find actually your position? To find this, the satellite basically takes a city, let's say that as city A, which is perpendicular to itself. Remember that the satellites are 20,200 kilometers approximately above the earth. Then the distance between the city A and the satellite is 20,200 kilometers simply. Now you are aware with the hypotenuse value of the triangle, that is the distance between your car and the satellite, and you are also aware with the side of the triangle, that is the distance between the city A and the satellite. To find the base of the triangle, that is the distance between your car respective to the city A, you need to use the Pythagoras theorem, that is hypotenuse into hypotenuse, hypotenuse square is equals to side into side, side square plus base into base, base square. By this, the numerical value of your car from that particular city is known. But dear friends, there are infinitely many possibilities of your car to be. in all the 360 degrees to that respective city. Here comes the work of a satellite number 2 doing the same job. After finding the value of satellite number 2 also, we can observe that there are infinitely many possibilities for this satellite also particularly. But when combined in a graph of city A, here comes two solutions, something like this. We can't just guess that we are present in any one of these points like that. To find the accurate position, we get help from satellite number 3. After doing the same procedure and plotting in graph, we will get an accurate position where we exist. In this way, all the 3 satellites will be showing us our way any time when we on our tracker in a time of milliseconds. This procedure is called as trilateration. This is how our GPS works in a time of milliseconds, nanoseconds. But even after completing all these calculations, there are still limitations and errors that creep in its accuracy. Number 1. Multipath errors. Multipath errors are those errors which occur while signals travel. GPS signals can strike with the trees, electromagnetic fields, buildings, and etc. After striking, these are reflected at a certain angle and thus increases the time to reach to the receiver. They can be corrected by introducing a stationary receiver at an high altitude. First, the GPS signal will be sent to that stationary receiver and then will be sent to the car GPS signal receiver. This method is called as differential method. Second error is called as almanac error. Due to the pull force of the sun and moon on the satellites, the position of their orbits are slightly changed. It can be corrected by updating the almanac. Almanac can be updated by the control department. Dear friends, like United States of America is maintaining GPS, in the same way there are many countries who are operating their own satellite navigation systems like India and many more. In India, this project is named as Indian Regional Navigation Satellite System or called as IRNSS. This also has an operational name, that is NAVIC, which means Navigation with Indian Constellation. India till now sent 9 satellites for tracking the people whoever they travel. Presently, they are restricted only to Indian Army. By 2020, they will also be available for civilians. Some examples of these satellites are IRNSS 1A, 1B, 1D and many more. Dear friends, hope this video gave you more information on this satellite navigation. Thank you.